Welcome to Rges Pre-Algebra. This is Lesson 23B, and we're discussing sections 6.1 through 6.3. We are going into a new unit now, and this unit will be on graphs, statistics, and probability. Now, I am not interested in covering this with the same depth of thoroughness as we would the others, so I'm going to just have you watch lesson 6.1 and 6.2 and just do a little bit of practice with graphing on your own. My biggest concern is that you know how to read a graph. So you will need your textbook for this, and I'd like you to go to 6.1 section or page 198, and we will be going through these answers orally. So go to 6.1, page 198. So if we look at problem 1, we're talking about a pictograph first off, where you see pictures. I'm sure that you've seen these kinds of graphs before. And in the first example, 6.1, you have leading pecan growing states. And we have Georgia, followed by New Mexico, followed by Texas, then Arizona and Oklahoma tied. Okay. Now, it says in the first question, what is the range? So to find the range, you want the highest number and the lowest number. Okay. The lowest would be 3 pecans, and the highest would be 3, 6, 9, 12, 14 pecans. But that's not what we're going to answer. We've got to pay attention to our scale. So our scale says that each pecan represents 5 millions. So our lowest number, 3 times 5, would be 15 million. And the highest number, 15 million. The highest number would be the 14 times the 5, which would be 70 million. So my range is 70 million to 15 million. And if I subtracted that, some people would answer that as the range, by the way, without a subtraction. But they're going to ask you for what is the difference between those two. So that would be 55 million. Number 2, what's the ratio of pecans grown in Oklahoma to pecans grown in New Mexico? Well, if the Oklahoma and New Mexico, so we would have Oklahoma in the numerator, and that would be 3, and New Mexico in the denominator, and that would be 3, 6, 9. And if we simplify that, that would be 1/3. Now, would that answer change if I had instead said 3 times 5 million or 15 million? Versus 9 times 5 million or 45 million. If you reduced, it would be the very same. So we do not have to pay attention to the scale for finding the ratio. Number 3, the number of pecans grown in Texas is what percent of the number grown in Georgia. So how many are grown in Texas? That would be 6. Again, to find percent is like a ratio, so I don't have to care about the scale. What is the number of pecans grown in Texas is what percent of the number grown in Georgia. How many are grown in Georgia? I should remember that. That's 14. Simplify. We always want our ratios and our percentages or in simplest form. So that would be 3/7. And then if you divide, you would have to divide 3 by 7, and you get 43%. That's a percent. Number 4, how many 5 million pounds of pecans are grown by the 5 states? So I would have to add them all together. 14 for Georgia, 9 for New Mexico, 6 for Texas, 3 for Arizona, and 3 for Oklahoma. And that would be 35. 5 million pound. How many 5 million pounds? So the answer would be 35. If you multiplied it by the 5 million, you would get 175. But they're asking how many 5 million pounds packages, basically. Okay. That's a LBS. Okay, 5. How many pecans are grown in Arizona? It would be 3 times the 5 million. So you're trying to get an idea of when you need to use that scale and when you do not. And so that would be 15 million. And now we're going on to the second pictograph. You always get yourself oriented. This has to do with passenger car production in 2017. We see that we have half cars, and we see that one car represents 1 million. What is the title of the pictograph? I've just read it. Passenger car production in 2007. How many labels are there? And the labels would be, so I did number 6, that's the title. Number 7, how many labels? The labels would be the things on the left-hand side. In the pecan growing, for instance, it would be Georgia, New Mexico, Texas, etc. So in the this pictograph, it would be Japan, United States, China, etc. And so how many of those are there? There are 6 labels. That could have been an obscure question, so that's what they're referring to there. 8, each car represents how many automobiles? We find that in the scale down below, so that would be 1 million. 9, how many cars did the U.S. produce? So we're going to count up those cars. We're going to get 3, 6, 9, 10, and 1/2. So what would that be? 10.5 million. 10, how many more cars did China produce than South Korea? So China produced 2, 4, 6, 8, 9. And South Korea produced 4. So that would be 5 million more. 11, what is the range of the statistics? The highest was Japan, which was 3, 6, 9, 11.5. And the lowest is 3. And so the range would be 11 minus 3 is 8.5 million. And that would be my range. And then 12, what 3 countries listed produce the fewest cars? And of course you'd read from the bottom up: France, South Korea, and Germany. Okay, so I think that is pretty clear for you. I'm not going to cover those word problems. Let's look at the sharpening skills very quickly. A collection of facts is called the data. Numerical data are called statistics. A graph shows data pictorially. The range of data is the difference between the highest and the lowest numerical information. And a pictograph is a graph that uses pictures to illustrate data. The rest is review, and I want to move on to the bar graph. So a bar graph, look on page 201, looks like this, where our data is being represented numerically from the in horizontal bars. The title of this graph would be diameters of the planets. Which type of bars are used? So you could have vertical bars or horizontal, but this is horizontal. Which planet is the smallest? That would be Mercury. Are the statistics ranked? Yes. What does that question mean? It means do they go from highest to lowest or from lowest to highest? Or are they in some kind of random order? They are ranked. Which planet is closest in size to the Earth? And that would, of course, be Venus. Approximately what is the diameter of Jupiter? So let me put it on pause so I can read that. So to be able to read this accurately, I have to notice on graph paper what does each little box represent. And here we notice if you're going from the heavier line to the heavier line, that represents 20,000 all the way, like from 80 to 100. That's 20,000. And so each bar has to represent 2,000. So if after 80,000, we're going to move up to 2, 4, 6, 7. So this would be 87. This is number 6. 87,000 miles. So if you're not real good at reading graphs, if you hadn't had much practice, I would suggest that you take a little time, make sure you can read a graph easily. You see, even when we're doing something like this, how much easier that is to, as we picture things pictorially, just to see, for instance, that Earth and Venus are very close to one another is just a glance on a graph, whereas it's a little more complicated when we're looking at numbers. Not that much more. Number 7, which planet has a diameter of 28,000? So we go over to our graph, and we see that it's going to have to be above 20,000. It's either going to be Neptune or Uranus. So Uranus, you count over, and you need, remember I said each box is 2,000. So if I have 4 boxes, 1, 2, 3, 4, would that be Neptune or Uranus? Or Uranus, I've heard it pronounced both ways. And the answer would be, of course, Neptune. So that would be number 7. Which planet is the largest? Just a glance at the graph, and that would be Jupiter. Now we've got a new graph here on page 202, selected accidental deaths in the United States. It says how many labels are used, and of course that, remember, that is how many lines being graphed from the left-hand side, how many different things we're graphing, and that would be 6. Firearms, airplane crashes, those are our labels. What is the biggest cause of accidental deaths? Just a quick glance, and the biggest cause of accidental deaths in the United States are poisons. That's interesting. Number 11, what killed approximately 3,300 Americans? And again, we have to decide what each graph represents. If we see the heavy lines going vertically, we see that that represents 10,000, and there are 10 small things. So each each little box represents 1,000. So it says what killed 3,300. So I'm going to look at 3 and a little bit more. And the 3 and a little bit more would be, looks like they're both a little bit more, fires and drowning. My eyes are not quite so good. I thought fires were less. Okay. And then 12, about how many Americans died from accidental falls. So we're going to find the falls, and it's over 10,000, and we're going up 8 more blocks, and so that would be 18, and then we're going to estimate. So about 18.8, or, okay, 18.75, maybe. It depends on how you would estimate that. So number 12, again, we're estimating. We see 18 blocks. We've got the 10 blocks plus 8 more blocks plus an estimate. Okay, so that should be 18.7 or 18,700, 18,800, about that. Number 13, the number of deaths by drowning was what percent of the deaths by poisons? Find the answer to the nearest whole percent. Okay. Now the deaths by drowning would be about 3.5 or 3.5 thousand. Let's say 3,500. That would be drowning. The deaths by poison would be almost 21,000. And so to take the percentage, we would divide like that, and we're going to get approximately 16%. Approximately how many Americans were killed in airplane crashes? Not quite 10,000. So again, you're going to estimate, and I'm going to say like let's see, I didn't mean 10,000, not quite 1,000. I'm going to say about 700. And hopefully you're reading along and you're seeing how I'm reading these. And are the statistics ranked? That means, do they go from smallest to greatest or from greatest to smallest? And the answer is yes. Okay, now we're on 6.3, and these are the line graphs. And line graphs, what makes them different from the others is you're going to be plotting singular points, and then you're going to connect them. You will connect them either by a straight line between the points or by kind of approximating a curve between them. So pay attention, which may be curved, broken, or straight. Now that's interesting, actually. They're describing this a little different. Okay, the curved one would then form an overall pattern. It's not going to be an approximation that'll be smooth like that, but it will be pointing up or pointing down from point to point. But the overall trajectory is smooth, or like this, up and down. So that would be curved. When you have the overall trajectory as up and down little hills and valleys, that would be called broken. And when the overall trajectory is straight up or straight angled down, those would be called straight. So it's the overall trajectory of the graph. Now in 6.3, if you look at page 203, we have the monthly normal temperature for Little Rock, Arkansas. So let's make sure you can read this graph, and then your homework will be to do the sharpening skills, which includes reading one of the graphs yourself. So let's march through these together quickly. And what we have is, what's the normal temperature during March? So you'll look at your graph and you will find March in the bottom line underneath the graph, and you go up to the point and you'll read 50 degrees. Which 2 months have the highest? So you'll go up to the very highest part of the graph, and you see that the temperature is actually 82 degrees, and that would be for the months of both July and August. Which month has a normal temperature of 40? I would go to the left-hand column. I'd find 40, and I would, which is, of course, the point between 38 and 42. So we recognize that each little, always ask yourself, how much does a little square represent on my graph paper? In this case, it represents 2 degrees. So 40 would be the very first point, and that would be in January. Which month has the lowest temperature? That is also the 40, and that's January. What type of line is used in the graph? That means, is it going to be curved, broken, or straight? It goes up and then down. That would be a curve. What is the title of the graph? Read right off the top. Monthly normal temperature for Little Rock, Arkansas. And what is the temperature range? That would be number 7. Well, the highest temperature would be 82. The lowest temperature would be 40. And so my temperature range is 42 degrees. Looking at the graph on the next page, we're almost finished here. This is a graph of commissions for Mr. Blue and Mr. Jones. We have the months on the bottom. We have the dollars on the left. Mr. Blue is blue colored and Mr. Jones is red. Which man showed the greatest improvement? So I'm going to do this 2 ways. I'm going to glance at the red graph and see it going up and down. And then I'm going to glance at the red and see how it has that long upward trajectory. So Mr. Jones showed the greatest improvement, number 1. How much did Mr. Blue earn in commissions in February? So Mr. Jones is the answer for number 1. Number 2, we're going to only look at the blue line. We're going to look February on the bottom, and we're going to read off $400. Number 3, what was Mr. Jones' greatest commission? And so you're going to look at Mr. Jones, which is the red line, and we're going to look for the dollar amounts. His greatest commission occurred at between 800 and 900 there, if you see that to the far right on the graph, and that would be, again, we're $50 for every grid box, and so we've got $850. Make sure you can read these numbers off accurately, especially that you can discern the value for every little block. Number 4, actually those are 8, 9, and 10. Number 11. How much more were Mr. Blue's commissions than Mr. Jones' commissions in June? So we go over to June. Mr. Blue had 600. And Mr. Jones, if you read on that same line for June, again, you go up. You've got 300, and you're going up one block. The blocks are worth 50, so his would be 350, and you take the difference, and that would be $250. And then number 12. What was the total amount earned by Mr. Blue? So you would just add them all up. You look at the blue line only. You're reading 450 plus 400 plus 450 plus 300, et cetera, et cetera. And I think you can read those all. And then your sum should be 5,500. Test yourself on that one. I'll let you look at that again. And number 13, how much more did Mr. Jones earn than Mr. Blue in November? Again, you go on November, down on the bottom line, and you're going to read Mr. Blue had between 300 and 400, that'd be 350. And I need to subtract that from November. That would be, Mr. Jones would be 850. And so subtracting, you would get 500. Okay, now for your assignment, so I'm skipping through most of this graphing because I think it should be simple for you, but you are going to read off one graph here, and a little bit later you're going to be producing just a couple graphs, and we'll call it an end on this chapter.